Welcome. In this tutorial, we are going to learn about recursion. So first topic is recursive function. A function which call itself is called as a recursive function. So these are the building blocks for solving a problem using recursion. So recursion, as we define, recursive function call itself. By calling itself, we are dividing a large problem at hand into smaller set of sub problem. Okay, and with recursion it will continue to divide that smaller set of sub problem into further smaller set of sub problem until we reach a smaller function that we can solve it at hand. Okay, that is the smallest set of sub problem which can solve it. It is known as a base case. So it will end recursion at base case, and base case will solve that smaller set of problem and it will return the result. And further down the recursion line, it will pass that solution and it will combine the result of a smaller set of sub problems into our original problem. Okay, and while doing that, before making a recursive call, whatever we are applying on the input function or input parameters, it is applied in a pre-processing block, and after returning from the recursive call, whatever we are processing, the return value which is written by the recursive call is come under the post processing block. Okay, so now we will see a demo function, recursive function, which will demonstrate how these building blocks behave or applies when it is executed with recursion. So as we can see here, we have defined a function recur n which takes one argument n, and it is recursive function because it is calling itself and it is dividing a problem which is given n into n minus 1. So it is reducing the size of a problem. Okay, second building block is base case. So how many times or until which case it need to recur itself. So it will call itself until n reaches to 0. Okay, and at the base case, whatever we need to process, we need to write it inside the base case. In this case, we are just marking that we have reached the base case and it will not further recur from this point. Okay, and it will return. Okay, so whenever this function is executed, even for the first time or for the non-base case, it will hit that this pre-processing section which is executed before making a recursive call. So it will be executed before. Okay, so it will recur until it reaches base cases, and after returning from the base cases, for all the non-base cases, it will execute post-processing part after completing recursive call. Okay, so now let's execute this recursive function and let's see what it outputs. As we can see here, we will compare it side by side with our recursive function. As we can see, it is called with value 5. First it will check it as it is a base case or not. It is not. It will execute the pre-process, make recursive call. Again recursive function with value 4 is executed. It is not base case. It will execute pre-process part, and again it will make recursive call. So let's check that process in slides. Okay, so this is our demo recursive function. Okay, and we are calling that function. So initially it is called with value here 5. Okay, so recursion call or a function call with value 5 is made. So it will check it is a base case, no, it will pre-process, then again it will make a recursive call of n-1, which is 4. So until here the function with value n equal to 5 is executed, but it has not completed its execution for value 5, so it will still remain inside the memory. When it will resume? Whenever the recursion with n-1, which is recursion call of 4, will return its final value. Okay, so this is the execution of n minus recursion n equal to 4. So it will further check it is a base case, no, so it will pre-process it and it will again recur, which will call recur n with value 3, and this will continue until we reach the base case, which is n equal to 0. So in this case it will execute the base case and first time it will return. So until it has reached the base case, these are the recursive function call which are still to be completed. So whenever it will return, it will resume n equal to 1 recur call, because last call which was made by n0 has written here value. Okay, so it will resume it and it will print ended recurring for 1. Same way it will execute, it will return, and afterward it will end for recur value 2, 3, 4 and 5, and whenever all the call is written, it will return its final value, which is written by the function. Okay, so this is how you can trace the recursive function. Okay, in this demo program we have not written any value, but generally after returning from the recursive function we are returning some value which will be the output of a recursive function. So let's see the real world problem which is solved by the recursion. So first example is calculating power x raised to n. So then here we can see that x raised to n, we can mathematically write that equation equal to x into x raised to n minus 1. So this is the way we can divide a larger problem into sub problems. So as you can here see that some problems are inherently recursive in their nature itself. So as we can see, for the calculating power, it is recursive inherently. Okay, so same function can be solved using recursion. Okay, so we will use same formula to reduce larger problem into smaller problems. Okay, and for the power function, we know the base case, which is x raised to 1 equal to x itself. So we will use that as a base case. So with this recursive function, as we can see here, we have written first it is a base case. So whenever x raised to 1 is encountered, it will return x itself, and for all the values which are not equal to 1, we will reduce the given problem into smaller sub problems using this same equation, x equal to a recursive call of x raised to n minus 1. So it will again recursively call until it will reach the base cases. So let's execute and calculate 2 raised to 16. As we can see here, it has calculated the 2 raised to 16. Now if we are not sure that how it has calculated the recursion, then we can use print function to print recursion step. Okay, so here before calling power function, in a pre-processing step we can print values of all the local variable, so we can know that what function calls are made. So let's execute again same function. So as we can see here, it has printed all the function calls. Okay, so we have begun our problem with 2 raised to 16, and as we can see here, at each recursion step it is divided into the smaller set of sub problem, which is 2 raised to 15, 14, 2 into 2 raised to 15, 2 into 2 into 2 raised to 14, until it reaches the base case. And on base case it will return, for this function call it will return true, which will combine with this 2 raised to 1, 2 raised to 2, and then it will combine the result into the bottom up manner by multiplying whatever the result returned by the recursive call, and at the end it will return the call for the 2 raised to 16. Okay, so this is how the problem which is inherently recursive, which is solved using recursive function or the recursion. Okay, now in this tutorial we will also demonstrate the iterative approach for the same problem. Why we are explaining the iterative approach also? Because iterative approach are more readable as compared to the recursive function. So as we can see here, we needed to write a function call using print statement in order to know what's going on inside the recursive call. Okay, but same solution we can write with iterative approach. Okay, and that iterative solution will be much more readable as we will solve this problem. Okay, so that is the one benefit of iterative approach. And other benefit of iterative approach is it might be sometimes much more effective in terms of execution time and in terms of memory consumption when comparing with the recursive approach, but that might not be the case for all solutions. Okay, sometimes well optimized recursive solution might outperform the iterative approach also. Okay, so that depends on the how you solve the problem. Okay, so there is no clear winner, but whenever we can write or whenever we can solve the problem into the iterative manner, we must solve it as an iterative approach. Okay, and when we are dealing with the new problems and which are inherently recursive in their nature, so first we can solve it using recursion to understand the problem, and then we can convert that recursive solution into iterative one. So we will do the same for the power function in here. Okay, so we know base cases and recursive call, so same we will translate it here. So we know the base cases, so in power function we are applying x raised to n. So x is multiplied by itself n times. Okay, so we can write the same solution using iterative manner. So we will iterate over n times and we will multiply result with x. So x is multiplied n time in iterative manner and we are returning the result of after the performing for loop. So let's execute the iterative approach. So as we can see here, it is returning the same result as we saw solve the approach using recursive function. Okay, so end result for the correct solution will be the same for the both approach. Okay, but the execution instruction for both of the approach is very different and you will get different execution and memory consumption for both of the approach. So according to the problem, you need to choose one of the approach, and sometimes you may encounter certain problems which are far more difficult to solve using iterative approach. So in those cases, there are only option is to use recursive approach. So it is quite useful for large and complex problems. Okay. Next example is factorial. So factorial can be mathematically reduced into sub problem. For n factorial, it can be written as a n minus 1 factorial into n. So we know this mathematical solution and we will apply the same reduction to our recursive function. Okay, so here we can see that we are dividing a large problem into smaller problems. So this is n factorial and we are reducing it to the n minus 1 factorial by separating n out of it. Okay, so we will reduce it with same, and we know the base case for the factorial is 0 factorial is 1 and 1 factorial is also 1. So these are the base case we know. So we will reduce the given n until it reaches the base cases. So we will reduce using the same equation, n into factorial of n minus 1. So we will return n into factorial of n minus 1, and for the base case we are returning its respective value. So let's execute it. As you can see, it has written the factorial for 6. Now if you want to check what are the function call it is making, so we can write again same print function, and in pre-processing step we can write whatever the call is made by that part. So here we are seeing that we are making this call. Okay, so if we again execute with the print function, as we can see, these are the call which is made recursively. Okay, so first call for factorial 6, it is evaluating 6 into factorial of 5. Okay, and combining result of all after making all recursive call, we are returning the result which is finally 720. Okay, Now we will solve the same function iteratively. So we know the base case. So if the given n is a base case, so we will return just 1. And for all the n which is not base case, we will iterate from 1 to n, and we will multiply the same number or the same value of a variable I here at each step from 1 to n. It is up to n minus n plus 1, so it will only iterate up to n. So 1 to n we are multiplying that number. So again, first we will execute and we are returning the result after the for loop. So let's execute it, the iterative approach. So as we can see, comparing this, it is returning the same result. Okay, now we will also print each step, iterative step, for the iterative approach. Okay, so we will print result and value of I at each iteration. Okay, iteration, here again we will print the value of I. Okay, so as we can see, for iteration 1, 2, 3, 4, this is the value of result and this is the value of I. It is multiplying it. Okay, so if we compare it with a recursive approach, so as we can see here, we are constructing iterative into the top down manner. Okay, so from beginning from 1 up to given n. And if we see here, for the recursive, we have beginning with the given value until 1, and we are combining or we are generating result from the bottom up. Okay, so we are calling from bottom up to the base case, and we are combining result in a top down manner for the recursive call. But here iterative call, we are just returning or iterating over 1 to given n. So for recursive function, we always know that it is going to call bottom up manner, because we are first dividing a problem of a given size into sub problem, and then we will be combining. So that approach is fixed. But with iterative, we can write it in a, for this problem we can write it in top down manner also and bottom up manner also. But for the other problem, there will be a preference depending on the problem for the iterative approach. Next topic is, or next example is Fibonacci number. So for this fifth function will return nth Fibonacci number. Okay, so we know the base case for the Fibonacci number is Fibonacci of 0 is 0 and Fibonacci of 1 is 1, and for the rest of the number from beginning from 2, Fibonacci number is calculated as a Fibonacci of n equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. So Fibonacci of 2 will be calculated as a Fibonacci of 1 plus Fibonacci of 0, which will be 2. and Fibonacci of 3 will be calculated as a Fibonacci of 2 plus Fibonacci of 1, which will be 1 plus 1 equal to 2, and so on. Okay, we will calculate until the given n. So let's write the recursive solution. So first of all, we will write the base case. We know that whenever it is returning value less than 1, which is 1 and 0, it will return itself. Okay, so we are calculating Fibonacci for any positive number which is greater than 0. So whenever it is written, whenever the given value of n is less than or equal to 1, it will return itself. So we know that it is executing the base case, and for all other non-base cases we will return same as how we calculate the Fibonacci number. So Fibonacci of n plus 1, n minus 1 plus Fibonacci of n minus 2. So until now, whichever the recursive call we have saw, it was making only one function call. So for the first time we have here encountered that in single function call we are recurring 2 times. Okay, so it will be this function will be having a different recursion cycle, you can say, or it will be executed differently than all of the above example. Okay, so we will see them in details. So this is how it will break the larger problem into the smaller set of sub problem until it reaches to the base case. Okay, in this case base case will be hit when the n is less than or equal to 1. Okay, so let's execute it. As we can see, it has printed the Fibonacci number for the sixth number is 8th. Okay, now we will check what are the calls which is made by this 2 separate function call. So as we can see here, there are 2 function call for each iterative call. So it will not call this second function until this function is returned. Okay, so whenever it is executing this and it is reaching here, and whenever function call for this part is made, until this function is returned, it will not further proceed. So it will again call recursion and it will calculate it further down the line until it reach to the base case, and until this function and all it other recursion part of it returns, this function will not get executed. Okay, so let's print the calling hierarchy of a given Fibonacci function. So as we can see here, we will compare it with the code. So we have call Fibonacci of 6, which is making call. If first of all it will check it is a base case, no, then it will make 2 function call, which is calling Fibonacci of 5 plus Fibonacci of 4. So first, before executing this, it will execute 5. So it is executed here. So again it will call 2 function. Before executing this, it will again execute 4, which will again call this 2 function. Before executing this, it will call this until it reach the base case. So again 2. Okay, so whenever it will be calling for 1 and 0, it will hit the base case, and this will return here. Okay, so for this it will return here, and we know this will get executed, and this function will return here, so this function will get executed again. Okay, so in order to trace it further more detailedly, we will see the slides. Okay, so this is our function, recursive function for calculating Fibonacci number. So as you can see here, we have made call fib with value 6, which will further divide that sub problem. As you can see here, keep that in mind, this n-1 plus n-2. So it will call these two function, but before making this call, it will wait for returning of this function. Okay, so this function fib of 5, again it will call for the two function because it is not base case, fib of 5 and 3. Again, before executing this, it will wait for execution completion of this function. So again it will call itself because it is not base case. Same way for fib 3, again fib 2, again it is not base case, so it will reach the base case here. Okay, so fib of 1, whenever it is called, it will return 1 because it is a base case. So for fib 2, first part of a function call is made, so again it will execute the second part of a function call. Okay, so fib 0, it is a base case, it will execute. Okay, now fib 2 will combine those results, so it will add the result value, so 1 plus 0, it will return 1 to the fib 3. So its left part is completed, it will call the right part of it. So fib 1, it will return 1, so it will add those two value, return value, it will execute return as a 2. Okay, 1 plus 1. So for fib 4, left part is completed, now it will call right part here. So fib 2, again it is not a base case, so it will again further divide into fib 1 and 0. Fib 1 is a base case, so it will return value directly 1. Fib 0 is a base case, it will again return its value 0 as it is a base case, so it will add those both value because it has executed both recursive function, and it will return value 1. Now for fib 4, as you can see, we have calculated both part of the function, it will add the value and it will return value 3. Now for fib 5, it has calculated left part, it will call the right part, which is fib 3, which will check it is base case. No, it will call fib 2 1. For before calling 1, it will call 2. 2 is not base case, again it will recur, which will call fib 1 and 2. So fib 1 will execute it first, it is base case, it will return 1. Left part is completed, calling right part. Fib 0, it is a base case, it will return 0. 1 plus 0, it will return 1. For fib 3, it is left part is completed, calling right part, which is fib 1, which is a base case, it will return 1. So both part is completed, it will add those result, so it will return 2. Now for fib 5, both left and right part is completed, so it will add those two result of those two calls and return to the fib 6. Okay, so this recursion cycle for the left hand side of a fib is completed. Now it will make call for the right hand side. So fib 4, again it is not base case, it will call 3 and 2. First it will go for 3, again recur 2 and 1. 2 is not base case, again it will recur, so it will 1 and 0. 1 is base case, it will return 1. 0 is also base case, it will return 0. Addition, same way, 1 is a base case, again return 1. Combining, it is, so left part is completed. Now right part, fib 2, again it is not a base case, it will recur 1 and 0. 1 is executed 1. fib0 is a base case, executed and return 0, combining, returning 1. Now both parties completed, it will add 1, 2 plus 1, return it 3. Now both parties executed, it will combine it and it will return the result value as 8. So if you see this many time, Fibonacci recursive function has made the recursive call in order to return the value for the given Fibonacci nth Fibonacci number, which is a 6th Fibonacci number, which is 8. Okay. So if we compare this with this, it is the same sequence. Okay. Now we will solve the same problem using iterative approach. Okay. So we know the base case for Fibonacci is 0. It is returning 0. Fibonacci of 1, it is 1. So we are returning same. If n is 1 or 0, then we are returning same n. And for all other than n, we are taking 2 base value, and for each step until reaches nth, we are making n as a n1 plus n2, and we are replacing n2 with n1, which is equivalent to, we are moving forward each step using this. Okay, so we are calculating the next Fibonacci number, and we are storing that Fibonacci number into n1, and we are storing the previous Fibonacci number n1 into n2, and we are iterating in each step and we are calculating it. So first we will execute it, and here we can see it is printing the same result. Okay. So if we want to check what is happening at each iteration, you can write the print statement, a print function, and print the value of a n1 and n2 variable at each iteration. Okay. So let's execute it. As we can see, for the first iteration, it is beginning from 0 and 1, which are the first two Fibonacci number. Then it is calculated the next Fibonacci number 1, and it is storing previous as 0. Okay. Now it will calculate. So this is the first Fibonacci number. Oh, this is obviously 1. Okay. So for next Fibonacci number, it has stored the previous Fibonacci number as 1 and current as 1. Okay. So it will add into the next iteration, and it will store the value of a previous Fibonacci number into n2. Again, it will calculate next Fibonacci number from the previous two Fibonacci number, which is n1 and n2, which is 3, and it will store into n1, and whatever the previous Fibonacci number, which was 2, it is stored into n2 variable. Same way, so for previous iteration it was 2 Fibonacci number 3 and 2. From that we will calculate next Fibonacci number, which will store into the n1, and previous Fibonacci number, which will store into the n2 variable. Okay, and this is the final answer. Next example is binary search. So it is used for searching in an object or a number within the sorted sequence. So we have a sorted sequence, and we want to know whether the given element does exist in the given sequence, and if it is exist in the sequence, we want to know the position or the index of a given element inside that sorted sequence. So here we will use list as a sequence. Okay, so binary search, how does it work? It work on the divide and conquer approach. So as the list is divided, list is already sorted, we will calculate the middle from the length of the list, and we will compare the given value with the middle value of a given sorted list. If the given value is greater than this value, we will search in the right part of it, and if it is less than this value, we will only search in the left part of a given sequence. That way we are dividing a large sequence into the half length at each iteration or at each recursion for searching a given element in the sequence. Okay, so this problem is also inherently recursive in nature. So in each step we are dividing a search space into half here in binary search. Okay, so we will see the recursive implementation of a binary search. So it takes 4 arguments, as you can see here. First is a sequence, which is given as a list. Next is a value which we want to search in the sequence, and start and end the arguments are the beginning index of a sequence that in which we want to search, and it is an end sequence, which is the last sequence in which we want to search. So we know in Python index begins from 0, so we need to pass 0 as a starting point and whatever the length of sequence minus 1 as an end in order to search in whole sequence. Okay, so as we know, as we explained in explanation of binary search, how it divides the search space, as we can see, we have written those 2 rules here. So first of all, whatever the given start and end index, we will calculate the mid index, okay, by using this formula, which is just finding the middle point of a given start and end, and we will check whichever the element present in the sequence at that particular middle position, and we will compare it with the given value. Okay, if it is equal to that given value, we already found that element and we will return the index of that element. So at that stage also it finishes its recursion. Okay, if it is not equal to that, then we have those 2 cases where if it is less than that, or if it is greater than if the given value is less than the value which is at the given sequence, so we will only search in the left part of a sequence from the middle point. Okay, so this is, we will search from the beginning and we will search for the left part, which is mid minus 1. So we have already checked the middle part of it, so we will now only check middle minus 1 up to from the beginning to middle, and if it is greater than that, then we will search from middle plus 1 up to the given end. Okay, so same function or the same logic will get executed recursively until we find that end is less than the start, in which case we have exhausted the search space until that further which cannot be shrinked, and until we have exhausted the search space we haven't found any element, so which means that that element does not exist in the given sequence. Okay, so for that sequence we will first find 17 from the list, so we know it is at the index 0, 1 and 2, so at the 2 index. So if we execute it, as you can see, element is found and it is at position 2. Okay, now let's try to find element which is not inside the list. Okay, so it will say that no element is found inside the list. Okay, so same way, if we execute it, if the given element does exist in the list, it will return position of that, and if does not exist, it will print no element exists in the list. Okay, now we saw that this is working fine, but how we want to know what is internally happening at each step of a recursion. Okay, so rather than writing a print function, we will now debug it, and we will see at each iteration what is the value of its local variable and the state of a function. Okay, so same function we have copied into the file, another Python file or module, and we will make a breakpoint by clicking here. Okay, so whenever this line gets executed, it will pass control to us, and we will right click and we'll click on debug our given Python file. So it will open debugger console here, and here we can see step over, step into, okay, step out the functionality. Okay, so we will press F8 in order to execute the next statement in the given sequence. Okay, so we have already called here the same function we have called for searching value 17 into the our given sequence. Okay, so as we can see here, all the variables in the current scope will be, we can see their value as per the, as we will progress it, it will change this variable value. Okay, and in PyCharm, whenever it is debugged, it will automatically print all its local variable value here also. So while debugging, we don't need to look down here. Okay, so as we can see here, it is already printing all this variable or the parameters value which is currently having. So as we can see, this is the sequence that we have passed here. This is the value which we are searching. So it becomes very handy. Okay, so we know start and end 0 and 9. For the first iteration, we have given value 0 and length -1, so it is having 10 elements. So it has, as we can see here, end is 9. Same value we can see here also, 0 and 9 here also. Okay, so we will now execute the function. Okay, so we will press F8 to progress. Okay, so first it will check is end less than start? No. So it will not go into the base case. Okay, it will calculate mid. So as we can see here, it has calculated mid as 4. Now it will compare the value at sequence mid 4. So we know at sequence at index 4 there is value 35 and we have given 17 value. It is not equal. It will again compare. Thus 35 is greater than given value, which is 17. Yes. So it will shrink the space between 0 and the index 4, which is current our mid. Okay, so it will recursively call to search a given value in the left part of a given sequence. Okay, so as we can see here, the next recursive call is made, and if we see the argument here, we can see we have these are the two static value, and as we can see here, the search space is shrinked. Initially we have passed 0 and 9. Now it is shrinked to 0, between 0 and 3. Okay, again and is less than, no. Again it will take mid from 0 and 3, which is 1. So it will compare the value 1, value at index 1, which is 11, to the given value. No, it is not equal. Is it greater than? No, it is less than. So it will go in else part, as you can see. So else will be executed as a, it will search in right hand side. Okay, so mid is 1, so it will search from 2, and end is currently 3. So it will again make recursive call, begin from 2 and end is 3. Again we will take mid of it, and it is 2. Again we will compare. Yes, this will compare the value at index 2, which is 17, which is exactly what we are searching. So it will return the string. Okay, and it will finish the execution call for all of the previously made call, and it will return the same string which is returned by the that particular recursive call to the print function, and it will, if we see the console, it will print that we have found element at a position 2. Okay, so this way, using debugger, you can trace each of the recursive call with their local variable value, so you can know, or you can tune your recursive function according to it. Okay, so same binary search can be written iteratively like this. So same way, we know we need to iterate it until end is less than start. Okay, so same way, so this is the base case. So when end becomes greater than end is generally greater than start, but when end becomes less than start, we will stop. Okay, so same way we will iterate until end is greater than start. So it will break out of loop whenever end becomes less than start. So we have written this condition same, and we are performing same calculating the mid value. Okay, for mid function is same, and we are checking also the same thing. Only thing we are updating is a 2 variable value at each while step. Okay, so same solution we have applied here, but we are just updating the value of start and end. So whenever the value at a given the sequence value at mid is greater than the given value, okay, so we are updating end as a mid part of it. So this is greater than then, so we just need to search into this part of one. So end will be shrinked from this to current mid minus 1, okay, and if it is less than, then it is less than the given value, then in this part of a function, so start will be shrinked from here to mid plus 1 here, okay, for the first step, okay. So same way, if we execute it for the same sequence and same input sequence, it will produce the same result, okay. So that brings us to end of the video.